today we are going to do section 9.5, which is on page 936, which is talking about counting. Okay, you might think that counting sounds easy, but it isn't. Counting is part of probability and it can get super confusing. So please pay careful attention and think very carefully about what I say. Okay, that's really the only way to learn how to do counting. Now let's turn to the following page, 936, and look at example 1. Now where we use the addition principle, which is there are 2 vegetarian entree options and 5 meat entree options on the dinner menu. What is the total number of entree options? Well, you might say it seems to be 7, right? 5 plus 2, and you would be correct. Okay, that is example 1. That's the addition principle. And that sounds easy enough, but things get worse from here. Now, let's look at the next example, okay? Now, the multiplication principle, which is more complicated. Let's read it. This is example 2 on the following page. Now, example 2 says, Diane packed 2 skirts, 4 blouses, and 1 sweater. Okay, so we have 1 sweater, 2 skirts, that sweater, that skirt, 2 skirts, and 4 blouses. Okay, fine. So then she needs to choose a skirt and a blouse for each outfit. So we need one of these. Okay, one of these. And then also decide whether or not to wear the sweater. So the sweater, the option is 0 or 1. That is, either have 0 sweater or 1 sweater. Whereas we'll pick 1 out of 2 skirts and 1 out of 4 blouses. Now the question is, what is the total number of possible outfits that she can get out of this selection? Okay, so then now we're using something called the multiplication principle, which is the number of sweaters. The options are 2. Okay, is sweater or no sweater. The number of skirts, there are 2 skirts, so the total is also 2. If there is no skirt, is not an option. And the number of blouses is 4, so the total number of 4. And we're going to multiply these things together. That is 2 times 2 times 4. That's the multiplication table, that will multiplication principle, which will give us the total possible number of outfits. In other words, some possible. So 2 times 2 times 4, that's 16 total. Okay, and what are the 16? For example, we can have the no sweater, okay, and then skirt A, and then blouse 3, that sort of thing, or sweater, skirt B, blouse 1, and so on. If you have the same skirt and blouse but a different sweater option, that counts as a new outfit. So that's how the 16 can all come out, and that is I find that more difficult to think of. Okay, so please consider this more carefully and figure out why this is the case. The thing is that if you have several options, each one can connect to an option of the other, and that's why everything is being multiplied. So let's go on and look at example 3 on the following page. Okay. Now, find the number of permutations using the multiplication principle. Example 3 on the following page. So let's look at example 3, where there is a swimming competition and there are 9 swimmers competing. Now, how many ways can they place first, second, and third? So then the way you consider this is you consider the placements. How many possible guys can win first place? The answer is 9, being there are 9 swimmers. So there are 9 possibilities that 9 different people can win first place. However, once somebody wins the first place, then what's left is there are only 8 people left. So there are 8 possibilities of winning second place. And then lastly, there are 7 possibilities of winning third place. So this is first place, second place, and the third place. And so the total by the multiplication principle is 9 times 8 times 7. That's the total number of possible arrangements, such is called permutations. That's the total number of permutations that 9 swimmers can possibly win first, second, and third. And whatever this number is, I guess we might as well crank it out. And 9 times 8 is 72. So what is 72 times 7? Let's figure that out. Is 72 times 7 equals 504. So that should be the answer. Let's check it. Yep, 504. Okay, that is correct. So then, so the next question is now how many ways can they place first, second, and third if a specific swimmer named A already won the first place? So we already know this. So first place is done. Okay, is won by A. So what about second and third place? So then if first place is already done by A, the second place will have 8 options left because A cannot win second place. A already won first place. So then, so there are only 8 people left. So they each have a chance of winning second place. And then third place will have 7. So the total now is only 8 times 7, which is 56. That's it. Ways of arranging the following ones, given that the first one, if you already know that the first one, the possibilities are shot. Okay, one person already won, so the possibilities are only following 8 and 7, and that is correct. So finally, how many ways can all 9 swimmers line up for a photo? So then we do the same argument here. Okay, the first position will have imagine 9 positions. Okay, each one has a possibility. So the first one has 9 possibilities. The second one has 8, and the third one, and so on. 7, 6, 5, and 4, 3, 2, 1. And if the last place, the 9th has no option left. Okay, you just have the last. Whoever's the last guy will stand in the last location to take a picture. Now in that case, then the whole thing is 9 times 8 times 7, 6 times 5 times 6, 4, etc., all the way down to times 1, and that is called 9 factorial. The exclamation point just means the number will multiply by every number before it that's less than it, 1 going down 1 at a time until it reaches 1. Okay, and that is called a factorial. It's a shorthand to mean that number. Now that number is huge, usually. Now in this case, 9 factorial is whatever that is. Let me show you how to do that. I think we talked about factorial before, but I'm not sure if we actually did it on the calculator. Where is the factorial? Aha, see? In my calculator, see that thing here? Can you see it? Is this thing zooming in? Let's see if I can get it to zoom in. Right there, see? Exclamation mark, right? So then if we're doing 9 factorial, then let's push in 9, okay? And then being that it's brown, I'll use the shift button, shift, push that. See, 9 factorial with the exclamation point and everything. So let's push equal, and that's the 362 whatever that the book says as well. So you know the book got it right, okay? So that is that. And then in general then, there is a formula for it. Let's look at the following page. Okay, on page 940, there's a formula here that reads PNR equals to n factorial over n minus r factorial. Now that might look cryptic, but it's not, because that is just another way of saying this, the thing that we just did. What happened here is that right now we have 9 people, okay, and we're choosing, out of 9, we have to choose 3 positions. So the formula then, it says that you will take 9 factorial, and following that formula, this is the same as 9 factorial divided by 9 minus 3, which is 6 factorial. In other words, So if you have 9 factorial divided by 6 factorial, then you just have the first three numbers left, which is y equals to 9 times 8 times 7. And then, in other words, this is a general formula to do this kind of problem. Okay, like you have 9 people and 3 positions. How do you choose this? Now, put it in the way the book says. Let's read this. This formula is very important, so please pay careful attention to it. Okay, and now given n distinct objects, okay, that's the 9 people, right? N is the 9 people. The number of ways to select R objects. R is the 3 positions, first, second, third. So R is less than n, right? So given 9 distinct objects, 9 people, the number of ways to select R objects, 3 positions, from the set is P and R equals to n factorial. That's n 9 factorial divided by n minus R. That will be 6 in our example, 6 factorial. And that's how you calculate. You can follow that principle to calculate stuff in general. So that it might look a bit odd, okay? This kind of stuff always make me feel puzzled. Like you have to think very carefully to follow this rule. So let's do an example. Example 4 on page 940, where we have a professor is creating an exam of 9 questions from a test bank of 12 questions. Okay, so how many ways can she select and arrange the questions? So she needs to choose. So the total number of stuff available is 12. So n equals to 12. This is example 4. N equals to 12, and then R equals to 9. Right? Yeah. 9 questions out of. So there are 9 positions to pick, and then so we have. So then we will apply the P and R formula. Okay, which will be equal to, so P and R is equal to 12 factorial divided by 12 minus what is it, 9? Yeah, that would be 3 factorial, and then and that will be equal to something. Now to calculate that, then let's do this thing. We have, let's see, 12 factorial. Okay, let's do the 12 factorial divided by 12 minus 9 is 3, divided by 3 factorial, which is just 6, but we'll type it in anyway. And that equals to whatever the book says. Okay, the 79 whatever, what, million? Yeah, etc. However, there is actually another way of typing this number in. This notation here is also written as NPR. Okay, and NPR is on the calculator itself. That's why I tell you this is important. Okay, this is so important that the calculator has a button for it to just do this exact formula. And to do that, let me show you here. Okay, the NPR button in my calculator is right here. Can you see it? Maybe I should stand over here to see if you can see it clearly. Let's see if, okay, see right here, the NPR, which I will use the shift to get it. Now to type in, for example, n is 12 in our case, okay? So I'll type in 12, and then I push shift, and then, see, there's the P coming out. And then R in our case is 9, and then push equal, and gives the same giant number, okay, whatever that is. So that can be done too, that your calculator has NPR built right into it. Okay, so that's that. Now, so far we have done things such that the things we choose, their order mattered. That is, we picked the first and second and third place. It mattered that one of them is first and the other one's second and the other one's third. What if it doesn't matter? We just want to pick 3 swimmers and it doesn't matter who's first or second. If that is the case, that is called a combination. Okay? And the combination has a slightly different formula. The combination is very similar to the permutation formula with the exception that there is another r factorial at the bottom, as we can see on the next page, page 941. Now on page 941, here's the other formula, which is also very important. That let's read this together. The given n distinct objects, those are the 9 people, okay? And the number of ways of selecting our objects from the collection, that is, we just want to pick 3 people. We don't care if they're first, second, or third. Just grab me any 3. If it doesn't matter, if the order doesn't matter, then the formula is called NCR. In this case, it's called Cn of r, which is very similar to the other one, with the exception of you have to divide by r factorial. The reason is because r factorial is the different ways that you can combine these people. So once you divide by it, then the order doesn't matter anymore. R counts the order with, basically the r factorial counts the order that these things can go. So now please think about that. Spend some time thinking about that until that makes sense. It's I've always found that to be somewhat confusing. Okay, and even when I think it through, I later might forget about it and then have to think it through all over again. But anyway, just think it through, and then you can quickly realize why that is the case. Now let us consider example 5. And so we have a fast food restaurant that offers 5 side dish options, and you can have 2 side dishes. So then we have so in other words, we're choosing 2 out of 5, but the order doesn't matter. That is, it doesn't matter if the first side, which one is the first side dish and which one is the second side dish. You're just going to take 2 of them, okay? And so then as a result, you're going to apply the NCR formula, which is the, let me write that down over here maybe. The NCR is, actually, let's not write it down. Let's just remember this. It's n factorial over r factorial and n minus r factorial. In this case, then it is Cn comma r equals to n is 5, okay, this is 5, r is 2. So we have 5 options, we're choosing 2, order doesn't matter. So then we have 5 factorial divided by 2 factorial, and then 5 minus 2, which is 3 factorial. That is following the NCR formula, or the CNR. So let's, that's example 5, so part A, in fact. So let's calculate this. We'll do 5 factorial, which is, doesn't matter what it is. Okay, let's type in 5 factorial. And then divided by 2 factorial is just 2, okay? Sorry, divided by, I forgot to do something here. Divide by parentheses. 2 times 3 factorial, which is 6, but we'll type it in for now. Okay, so that looks okay. And that gives me the answer of 10, which is, let me see. Yep, and that is correct. Okay, so that's always good. So the ways, if you have 5 options and you only want to choose 2 out of them, doesn't matter which way, which is the first choice or second choice or nothing like that, then it is called then you have 10 ways of picking 2 out of 5 things. Now again, the NCR is also on the calculator. There's a specific button for you to do NCR, which is in my calculator right over the division line. See right here, let me see if you can see it properly. Let's see right here over the division symbol, the brown part where it says NCR. Yeah, that, so you use the shift and then the division symbol. Okay, this is just a cheap calculator, and even it has this. So that shows you how important NCR is. So to do this case, n is 5. Okay, let's push in NCR. 5 shift C. Wait a second, what? Give me a second here. What is that? I don't know what happened there. I think I pushed the wrong thing. Okay, try again. Shift and C. Yep, there's a C. And then 2, right? 5, choose 2. it equals 10. So that is so you can use that button and don't have to type in all the factorials if you're doing NCR. So that is part A. Next, what is part B? How many ways can you select 3 side dishes? Okay, so then you just do 5 choose 3 instead of 2. Okay, so in my case, I'm just gonna go back and delete the 2 and put 3 in there, and that gives me also 10. Okay, that's because well, that's that they're the same. Well, anyway, so then that's that, and that is NCR. Let's see. So anyway, so next, let's look at example 6, where we have a restaurant offering butter, cheese, chives, and sour cream. That's 4 things, right? As toppings for the baked potato. So how many different ways are there to order the baked potato? Well, each topping is similar to this story right here. Let's see, where did we do this? It doesn't matter. The multiplication principle that we mentioned earlier. That is, each topping is a yes or no situation, right? So each topping has 2 options. So we have 2 for the first object, butter, is a yes or no. So 2 choices, and 2 choices of butter, 2 choices for cheese, and then 2 choices for chives and 2 choices for sour cream. By the multiplication table, then we have 2 times 2 times 2 times 2 number of options, which in this case is 16. Now, in general, if we have however many items that we're picking from, okay, if each option is a yes or no option, okay, is butter or no butter, that's your option. Then the total, in general, then is 2 to the power n. N is the number of objects we have, and each one has 2 options. So the total is multiply themselves n times, and that's where this formula is from page 942, right here. And that is also example 6, okay? And we have 4 objects, each one's a yes or no option, so the total will be 2 to the power 4, which is 16. All right, so the next thing we need to consider is we have a number of things to pick from, but they are all distinct so far, okay? They're like we choose, the people are not, there are no people that's the same, they're all distinct people. But let's say at the bottom of the page here, of this page 942, let's say we're picking stickers. Then some of the stickers are the same, which confuses things a little bit. Okay, so then how are we going to calculate if they were if some of the stickers are the same? So here's the formula for it. So let's go back to this example right here. Okay, and I should write down the page number. We are on page 942, but let's consider this thing that we did earlier. This is when we had 9 swimmers, and we have tried to figure out the different ways we can line them up to take a picture, okay? And then we decided that eventually that there's a 9 factorial number of ways. That is 9 times 8 times 7 all the way times down to 1. Whatever that giant number is, that's how many different ways that they can stand to take a picture in different positions. Now the question now is, what if some of the people are the same? Well, how can people be the same? Well, let's say they're clones or something. Okay, let's stretch our imagination a little bit and pretend that some of them are clones to the point that they're so identical down to the DNA level that there is there's no difference. That is, turning them around doesn't change the arrangement at all. They are completely identical. Now, in that case, this counting formula has to be divided by the number of clones we have. The general formula follows this. Okay, so in this situation, then we have to divide by the various clones. Like, say if there are 3 clones here, there are 3 of them are clones, and then something else is to have 2 clones or something, then we divide out all the clones like this. That way we don't have repeats as a result. So this is how to count the number of stuff, if the total variation, if there are clones in there that are completely identical. So as a result, let's look at example 7 on the following page. Now, number 7 on page 943 says, find the number of rearrangements of the letters in the word distinct. Now, isn't that funny? Okay, normally we would just count how many there are. 1, 2, 3, and then 5. That's 8 letters. Okay, so normally there would be just 8 factorial ways of arranging it, just like this. There's a 9 factorial way of arranging the 9 people, and there's 8 factorial way of arranging the 8 letters. However, the thing is, however, there's a repeated situation. What are being repeated? Let's see, distinct, it has I is showed up 2 times, so we need to divide it by 2 factorial. And what else? T, I see T showing up 2 times, so that also need to be divided out. Anything else? This DIS, TINCT. Yeah, it seems like that's it, right? So we just have to do 9 factorial and divide it by 4, and that will give us the right answer. So let's do that. Let's see. Okay, let me turn on my calculator. All right, let's do 9 factorial divided by 2 factorial is just 2. So because it's 2 times 1, so 2 times 2 is 4. So we'll just have divided by 4. That's what was that, 90,000 something? And let's see if I got it right. No, sorry, it's not 9. I was stuck with the problem over here. It's not 9 factorial. It's 8 factorial. Distinct has 8 letters. That's what I said too. I don't know why I suddenly said 9. Let's turn it into 8 and try again. All right, so I will go back, and there's my 9. Let's get rid of it and enter 8 instead. Here, now is what, 10,000 something, which looks much better. Okay, it looks better because it looks just like what the book says. That's why it looks better. All right, so we have come to the end of this section. Now, right now we're doing this kind of counting, which is a part of probability. It's somewhat odd, okay? So please patiently think about it, and then read each condition of the NPR and the NCR carefully. Remember what they mean, and as well as the 2 to the power n and the permutation. And so once you've done that, the problems actually comes very quickly. I mean, you can do them, and most of them are fairly short, as long as you keep track of which formula to use. So let me look at the homework. So for homework, please do problems 9, 13, 27, 31, 35, 43, 47, 49, 51, and 53. And they are all quite similar to the examples. So if you get the examples done, then they should come quite quickly, because most of them are very, very short. Okay, you just have to imitate the examples exactly, and everything should come out. And that will mark the end of this section.